so first thing we're looking for is a GCF. Perfect. Do I have one? No, I don't, because this little one here kind of messes me up, right? Alright, so then now what do I look for? Yeah, AC method. How did we know it was AC method from there? Huh?
Y squared, y, and then no.
Yeah, I got y squared, a y, and then no y whatsoever. Alright, so AC method. Somebody different, go ahead and give me how I run that. Yeah, Callie? 2 times negative 10 gives me negative 20. Somebody different, give me what I do from there. Yep.
You're going to add to y, so negative 4 plus 5.
So we have multiply to get the negative 20, but add to get the 1 in front of the y, and you said that was what two values?
Negative 4 plus 5.
Is perfect. Negative 4 and 5 is correct. Questions on that so far? Alright, somebody different, give me the next step. Yes? Make it a fraction. So how do I set up my fraction here? So the 2y. If you change the y's to x's, some of you guys were asking me that on your homework, that's fine. You don't have to have the same letter there if it bothers you to have that letter. Alright, somebody different, give me what I do now. Yep. Negative 4 and 5 go underneath. Perfect. Somebody else?
Put it in parentheses.
No. Yeah. I can reduce the 2 and the 4. So make sure you reduce the 2 and the 4. Gives me a 1 and a negative 2. Alright, Dylan, now what do I do?
Parentheses.
Parentheses. So what are my parentheses at this point, Dylan?
1 and minus
Y minus 2 and?
Yeah. Y, 2y minus 5. That's 5, or plus 5.
There we go. How many of us got that? Perfect. Alright. Alright, so then number 2. Somebody different I haven't heard from yet. What do I do first here? I want to, is it Paul? Paul, right?
Yeah.
Yes.
You multiply negative negative 1 times negative 16.
So you're noticing that it's AC method, which is perfect. But, Jason, help me out.
You have to take the negative 1 out.
Why do I have to take the negative 1 out?
They have to be positive.
A has to be positive. Don't forget that first check, because your homework didn't really harass you with it. That's why I kind of set you up for failure here, so that you can kind of remember. Okay? So, it's perfect that you recognize AC, but remember first always look for GCF, and as you're looking for GCF, ask yourself, is there a negative in the front? This is going to hold true for today's formulas as well. If there's that negative in the front, you have to pull it out. Because I don't have a GCF, we're pulling out a negative 1. So that gives me m squared plus 10n plus 16. And then Paul would be completely correct, because at this point, I have a 1 in front. I'm going to take 1 times 16. So that was perfect that he's recognizing it from there. Okay? Somebody different, give me my next step that I haven't heard from. Yes?
8 times 2 equals 16.
Yeah, so 8 times 2 is 16, but 8 plus 2 is 10. Remember, there will only be one set, and double check your signs. Make sure that they are answering the question correctly from the sign. Okay, somebody different, give me the next step. Yes?
You set it up as a fraction.
So set my fraction up.
10n over 8 and then over 2.
What is your A? Oh, 1. So 1m over 8 and 1m over 2. Perfect. From here, somebody different. What am I looking for? Somebody I haven't heard from yet. Or I can start calling and practicing names. Yeah?
Parentheses.
Parentheses. How do we know that we can go straight to parentheses here, but then it was wrong when they said straight to parentheses before?
Because you can't
Dylan?
Because you can't reduce.
I can't reduce that. So I can't reduce that. It's going to go straight to parentheses. So go ahead, Kyler, and give me my
1n plus 8
perfect.
and 1n plus 2.
Perfect. Remember, you don't have to have the 1s in front of the m's. You could just have m plus 8, m plus 2. Most important, that negative 1 we pulled out to start needs to be carried down inside of the answer. Don't forget about that. How many of us had that as our answer?
Can we just put like a negative, or does it have to be negative?
You could just do a negative in front, yes, because the 1 would be implied. Questions on there?
Do you have to write the 1 in front of the answer?
No, we just did that. No.
So,
Alrighty, take out your assignment so that we. Alright, here we go. Number 1 is x minus 9 and x plus 2. Could be in any order. So the order does not matter, but the sign does. So in other words, if they had x plus 9 and x minus 2, that would be wrong. But if they just reverse the parentheses, it's correct. Does that make sense? Yes, nobody's answering me. Okay. Number 2 is b plus 2 and b minus 7. 3 is m minus 1 and m minus 8. 4 is x minus 9 and x minus 7. 5 is 7x plus 4, x minus 5. 6 is k, and then 7k plus 9. Seven is 7x plus 4 and x minus 7. 8 is 2b plus 3 and b plus 7. 9 is 5p plus 9 and p minus 2. 10 is 4n squared on the outside, and then 7n minus 10, n plus 2.
For number 9, if they put like a 2p minus 5, is that wrong?
They put what?
2p minus 5?
No, that's wrong. 11 is b, and then parentheses 3b minus 2 and b minus 1. 12 is 7x plus 10 and x minus 6. 13 is 3b, and then 2n minus 5, 5n minus 2. That is the conclusion of the assigned problem. So at this point, if they miss the problem, then go ahead and like circle it, but don't count it wrong. If they get the problem correct, put a plus 1 next to that problem. Number 14 is not factorable. 15 is r, and then parentheses p plus 7, 9p plus 10. 16 is not factorable. 17 is x on the outside, and then x plus 10, 4x plus 3. And finally, 18 is m plus 9 and 10m minus 1. Again, on the 14 through 18, it's plus 1 if they got it correct, but we're not counting it wrong if they got it wrong. Alright, do not do italics. They're still working. Give them their problems back.
so do we just put plus 1 on all the
14 through 18. Alright, what I'd like to do at this time is go ahead and go into notes, and then we will go back, and if you have questions, we'll go over questions so you can mark them correct. The only ones obviously I won't do are the extra credits, but everything else I'll go over with you. And then that way, if we're doing one you don't need, you can get started on today's assignment. Okay? Make sense? So your notes should be out. Notes first, and then we'll do that. Alright, so we're going through our factoring methods. The one that we won't be doing for this go around, there's just one of them. That will pick up in a few months, I think, the last factoring method. All of these are really more quadratic types of factoring methods. So the first factoring method that we covered up to this point is a GCF. What was the GCF again? Greatest common factor. So what did we mean by that again? The highest letter or number that goes into all. So this is the highest letter or number that divides into all. That was our GCF. The other one that we did was AC method. And when do I do AC method? Y equals mx plus b is a line. It's a different type of formula though. Somebody help her out. When do we do AC method? When do I know to do AC method? Paul?
Like greatest common factor does not apply.
No, you can pull the greatest common factor out. So we'll talk about that in a minute.
mx squared plus b squared or bx plus
Yeah, it's ax squared plus bx plus c. You fit that format of some sort. Some of you guys learned, I think that was what, number 6, where you had only the 2, and so you pulled k out as a GCF and you knew you were done. And some of you remember you were trying to set c up as 0. You can't do that. You have to fit this format. Sometimes b can be 0, but typically nothing else is going to be 0 if you're going to do AC method to run this. And then we're just going to make a note that this is the fraction trick. We're not going to rewrite all those steps, but we're just going to remind ourselves that the AC method is where we do the little fraction. Alright, so we're moving on then to the third factoring method. This one you should have heard before, you should have used before. And what I always like to say is that this one is the easiest one, and yet it's the hardest one to remember. It's typically the one that we always forget very first thing. Like tomorrow you'll probably forget it, right? So it's the one that we sort of neglect. And that is what we call the difference of squares. Yeah, see? What does that sound like if I'm saying difference of squares? What would you think is happening in your problem? Yes?
Subtraction squared.
Yeah, you have 2 squares that are subtracted, right? We all can kind of get there. So difference of squares is when you have 2 squares that are being subtracted. And we are going to like triple underline subtracted. Alrighty, so let's look at an example and kind of build where this formula comes from. So what I would like to do is take x plus 2, x minus 2, and I'd like to redistribute that. So if I redistribute that, I have x times x. What is that? X squared. X times negative 2. Then I move on, 2 times x. And then 2 times negative 2. Good so far? And then what happens?
You add your x's together.
I add my x's together, and what's negative 2 plus 2? 0. These cancel. What am I left with? 2 squares being subtracted. Why are they 2 squares? Well, because my parentheses were exactly the same, except for the plus and the minus. So I got the squares because the front number were the same, the back number were the same, and that gave me the front and the back squares. The middle dropped out because these were 2 different signs. Does that make sense? So the philosophy behind difference of squares is that that will always happen. If you have 2 squares, notice you're missing the bx part. So we might want to make a note on our definition. That you're missing that bx, you're missing that middle when you do difference of squares. So that my formula then is going to take this backwards. It's going to say if I have 2 numbers being subtracted, so a squared minus b squared, I have 2 squares being subtracted, doesn't matter what letters are there, doesn't matter what numbers are there. If I have that, then I know that their 2 parentheses must have been the exact same 2 numbers added in and subtracted. It won't matter the order that they fall, as long as one is positive, one is negative. Does that make sense for the difference of squares? Alright, because step 4, before we do a couple of examples, is going to be the difference of cubes. Difference of cubes, what does that sound like?
Same thing, but with cubed.
Yeah, same thing but with cubes, right? So we have 2 cubes being subtracted. What do we mean by a cube?
The exponent of 3.
Yeah, it's the same number multiplied 3 times now, instead of just twice. Okay? I'm not going to show you where the formula comes from just because it's a little bit more chaotic. But it's the same philosophy, that when you redistribute the 2 parentheses, everything in the middle drops except for what you had, the cubes in the front and the back. So this formula is a little bit obnoxious. We're going to do this formula and then the formula for the sum, and then I'm going to tell you how I do it, as far as I don't memorize 2 different formulas. So for this formula, you have a cubed minus b cubed equals. The first parenthesis is pretty much the same as the first parenthesis of the difference of squares. You just need to make sure you're matching the minus here. So I have a minus b. In other words, if I had an x cubed and an 8, so I had x cubed minus 8, then this would be x minus 2, because 2 times 2 times 2 is 8. So you always take the singled out version for that first parenthesis. The second parenthesis is longer because it takes more to drop the middles if I'm talking about creating cubes here. And then inside of it, we're going to do a squared plus ab plus b squared. And what that's telling you is if you refoil that out, just like in the difference of squares, you're going to have a lot more, right? But just like in the difference of squares, all the middle is going to drop, and all you're going to be left with are these cubes being multiplied in the front and back. But then the cubes are a little bit more tricky because they don't just have a difference of cubes. They have a sum of cubes. What do we mean by sum? Addition. So now these are going to be 2 cubes being added. Did I have a sum of squares? No. Sum of squares does not exist. The cubes are the only ones that can go in both positive and negative, both plus and minus. This formula is the same, so x cubed plus b cubed now though. First parenthesis is going to be the same where I take a, but now I'm going to match it still, so a plus b. A squared minus ab plus b squared. What I want you to notice in all of this is that the front sign matches. So if it's a minus, I had a minus. A plus, I have a plus. And then these 2 parentheses are exactly the same except for the plus and the minus. So that's where our procedure is sort of going to come in. Because this sign and this sign are opposite. Why are they opposite? Because I have to cancel out all of the middles. So let's do a couple of examples. As we do the examples, I'll walk you through how I do this factorization. Okay? Can I flip this? Alright. So, number 1, for our example, x squared minus 81. Am I looking at squares or cubes here?
Squares.
What should clue you in that you're looking for squares? X is to the second power. Does that make sense? So use that X to guide you. Alrighty. So what are my two parentheses then? Where do they get 9? Because 9 times 9 is the 81. What am I looking for here? I'm looking for cubes. How do I know I'm looking for cubes here? Because X is cubed. Does that make sense so far? Alright. Now the question, and this is what makes the cubes harder. The cubes are harder to sort of identify because we don't really remember them, right? So that's where a calculator would be handy. But what times itself 3 times is 64, Paul?
I believe 4.
4 is correct. Hazen, you still with me? Make sure we stay focused, okay? Alright, so the first parenthesis is going to be what?
X minus 4.
X minus 4. Everybody see where they get the first parenthesis? Alright, now this is how I do the second parenthesis. I always do them the same. So the second parenthesis is going to be long, right? Alright, take the first number, which is X, and square it. I get X squared. Multiply them together, I get a negative 4X, but change the sign for X. Square the back number, and I get plus 16. Remember that when you square, you always get a positive. Make sense? 25 minus 9x squared. When you start getting a lot of numbers, you still want to look for GCF first. Do I have one? No GCF here. What am I looking for? Squares. Are they all squares? Yeah. 25, what is that? 5. 9, what is that? 3. So what are my two parentheses?
Out of 3.
3x.
Careful. What comes first? What comes first here? 25, so what comes first here? 5. And then minus 3x and 5 plus 3x. Perfect. Good so far? Alright. 4. Let's do 8x cubed plus 125. What am I looking for? If they're cubes. Is 8 a cube?
Yes.
2 times 2 times 2. Is 125 a cube? Yeah, it is. What is it? 5. Alright, so what is my first parenthesis? 2x plus 5. I'm only hearing about 2 people talk to me at this point. Are we all else getting it though? Making sense to us? Like I said, use a calculator to figure out your cubes because those are not ones we typically memorize. Alright, here we go. Procedure is still going to be the same. 2x, if I square it, what do I get? Careful. 4x squared. Multiply them together. 10x, change the sign. Minus 10x. Square the back. Again, I don't remember the formula, I remember the procedure, and the procedure does not change. Alright, number 5. We will do x squared plus 16. So how many of us on our paper are writing x plus 4x minus 4? X plus 4x minus 4?
Oh, no, you can't do that.
Jason, did you say you did that? Why not?
Addition.
Because he's saying x plus 4, okay? Well, if he's saying x plus 4, you're telling me that it's not the difference of squares? Because that one had minus and a plus, right?
Subtraction.
Paul, say that louder.
It's not subtraction.
Is that a subtraction? No, it's an addition. Let's evaluate, let's look at. So we'll kind of come off to the side and make a note. Because the way that we want to go is exactly what he did, which is x plus 4. It makes sense to us, right? But let's go ahead and FOIL that out. What is x times x? X times 4? 4 times x? Positive still. 4 times 4? So the only way to get the positive 16 in the back is if they have the same sign. But if they have the same sign, are those going to drop? No. This becomes x squared plus 8x plus 16. This is not that. Is there any way then that I can get a positive 16 in the back and drop the middle? Divide by 2?
All the way around.
Well, then I'd have a fraction in the front.
Sorry, I mixed up. I got the square.
This is not factorable. There is no way that you can get the squares. Because remember, the squares are telling you that the parentheses are the same. Because we got the squares. But it has to be a minus because these two have to be different signs. And if these two are different signs, then they can drop. Okay? Alright. This one I want you to do on your paper. And then I will set you free. So x cubed minus 8. So on your paper, I want you to work that out.